So to determine if this improper integral converges or diverges, one way we can do it is to just solve it and see if it equals a number. If it equals a number, it converges. If it doesn't narrow in on a number, then it diverges. All right, so first step is to write this as a limit. This is the limit as r approaches infinity, 0 to r, x e to the negative 2x dx. And so our first task is to compute this integral. This, you'll notice, is a good candidate for integration by parts. I'll use the table method. You've got u and dv. For u, I have x. So taking multiple derivatives, derivative of x is 1. Derivative of 1 is 0. And here we have e to the negative 2x is my dv. Now taking repeated antiderivatives. Let's see, the antiderivative of e to the negative 2x dx. Now you could use a u substitution. U equals negative 2x. What you'll find is that the antiderivative will be 1 over negative 2 e to the negative 2x, of course, plus c, but we won't write that there. So we have negative 1/2 e to the negative 2x. And now think about if we were to take the antiderivative of that again, right? That would be the same as putting a negative 1/2 out front. So it'll actually just be doing that. So let's see, that'd be 1/4 e to the negative 2x. Okay, do our signs, plus, minus, plus. Draw our arrows, like so. So this is equal to the limit as r approaches infinity. We found our antiderivative. Let's see, this was negative 1/2 x e to the negative 2x minus 1/4 e to the negative 2x. We're going to evaluate this from 0 to r. Okay, this is the limit as r approaches infinity. And now we'll evaluate. So we have negative 1/2. R goes in for the x's. We got r e the negative 2r minus 1/4 e to the negative 2r minus, now putting a 0 in to this one here, right, into that, that'll give you a 0. So we have 0 minus, now putting a 0 in there, we have e to the 0, so that's 1. So minus 1/4 times 1. Okay. Now we can split the limit over each of the expressions and pop out the constants. So negative 1/2 limit r approaches infinity. I'm going to write this as r over e to the 2r minus 1/4 limit as r approaches infinity, 1 over e to the 2r. And now, let's see, minus 1/4, so that'll be plus 1/4. Okay, now think about what happens. Okay, let's take care of the easy one first. Right, 1 over e to the 2r as r approaches infinity. E, if you remember that e to the x looks something like that. It grows exponentially, so e to the 2r grows even faster. So 1 over gets big is small, right? So this is a big 0 here. And if you think of dominance, e grows so much faster than r. This is also a 0. You could use L'Hopital's rule there if you wanted to. But the answer, as you can see, is 1/4. And so it goes to a number, so it converges. What does it converge to? It converges to 1/4. Let me show you this. The limit as r approaches infinity. If you don't like using the dominance, you can use L'Hopital's rule. R over e to the 2r. R, the function y equals r, that's y equals x, that goes to infinity. So you do have infinity over infinity. Indeterminate form, so we use L'Hopital's rule. So the limit as r approaches infinity. Derivative of r is 1. Derivative of e to the 2r is 2e to the 2r, which you can see equals 0. So that just verifies what we found here, that it was 0. All right.